students, in this session I am going to explain the next concept in C programming language, that is unions. In the previous session we have seen structures in C language. What is that structure? Structure is a user defined data type that will group together different data type elements. To represent any object like student, marker, complex number, bank account, we can use that structure. Let you want to store data about any student, then that will have roll number, name, marks, division of that student, address of that student, in this way. Now roll number is of type integer, address will be of type character array, means string, name is again a string, then division of that student may be a character type value, means different data type elements. Suppose you want to group together and create one user defined data type, then what we use? We use structures. In the same way, there is one more data type provided by C language, that is unions. Now why it is provided? Now what is the difference between that structure and union? Everything we have to see in this session only. Now see, what is union? Union is again a user defined data type that will group together different data type elements. Again same thing. Here union and structure, for that you can write this same definition, that is, it is a user defined data type that is used to group together different data type elements. Now what is the difference? Whatever memory allocation, in that there is a difference. Means suppose we have created one structure like this, struct let number, and inside that let there are two variables. One is of type integer, let a, and character, let like ch. This one is a character and its ASCII value we are storing inside that a. Here whatever space allocation for one variable of that structure will be like this. Here for integer variable it will take 2 bytes. Here I am considering 16-bit system. If it is 32-bit, then consider 4 bytes. And then for one character, 1 byte. That's why totally how much space will get allocated for this? 2 plus 1, 3 bytes will get allocated. Means what? For one variable of that structure, whenever we create variable, then only that space will get allocated. Getting? Means here suppose we are creating one variable of this structure. Here we can create variable like let number 1, num1. Now num1 is a variable of type struct number. Now how much space will get allocated for that num1? 2 plus 1, that is 3 bytes will get allocated for that num1. First 2 bytes for a and 1 byte for that ch in this. Getting? That's why total 3 bytes will get allocated for that one variable of num. Now what is union? We have seen the syntax, how to declare structure. We have to write struct keyword, then here whatever name you have to give, that structure name, and here whatever members of that structure you have to mention. Member means nothing but different elements with data type. Means one integer variable, then second one is character variable. In this way you can group together multiple data type elements here inside this structure. The same syntax will be there for union, only the difference is instead of this struct keyword we have to use union keyword. Now what is the syntax? First I will explain and then I will discuss about that what is the difference in between that structure and union. See, what is the syntax to declare union? Simple. Union keyword we have to use. Then tag. Tag is nothing but any name we can give to that union, and here we have to mention the members of that union. Members should be defined just like variable declaration. Okay, like here I am declaring one integer variable, character variable. Inside here those are nothing but members of that structure and union. Okay, because same structure we have to follow. Here we have to give semicolon. Getting? See, using that syntax I am going to create union number. Here again same thing is there, like let one integer a and second one is character ch. Means this is the integer variable, this is character variable, and that we are grouping together in inside one union. Now here same thing is there, here again same thing. Suppose we have created one variable of that number union, let it is again number 1. Now here instead of this one you are using this union concept, then what will happen? Inside a memory whenever the space is going to be reserved for this num1, how much bytes will get allocated here? Only 2 bytes. Only 2 bytes for that num1. Why? Because in case of union, the memory allocation for one variable of that union means whatever member of that union having maximum requirement of storage, that much space will get allocated for one variable of that union, and that will be shared by all the members. Getting my point? See here, whenever we create any variable of that union, then how much space will get allocated? Whatever member having maximum requirement of storage, that much space will get allocated. How much space is getting allocated in case of structure? Whatever space requirement for all the members, that will be added, and that much space will get allocated. Here this member requires 2 bytes, this member requires 1 byte, that's why 2 plus 1, 3 bytes will get allocated for this structure variable, one variable of that structure. And here whenever we create one variable of that union, then whatever big requirement, whatever higher requirement of storage requirement of any member, that will be checked. Here this requires 2 bytes, this requires 1 byte. What is the higher requirement? That is here 2 bytes. That much space only gets allocated for one variable of that union. Now for num1, only 2 bytes will get allocated, like 2 bytes. Then how these 2 variables will be stored? At a time, only one variable can be stored here. Means that 2 bytes will be shared by all the members of that union. Now here either this space will be used by this A, the whole 2 bytes will be used by A, or from that 1 byte will be used by that CH, in this way. But at a time you can either store A or you can store CH. At the same time you cannot store both. Getting? Means whenever there is a requirement, like you want to store any one member at a time. Okay, means here there are 2 members of this union, but there are 5 members. Again the same thing will happen. Whatever highest requirement, that much space will get allocated for one variable of that union. Means there is one float variable, let x, then next one is integer variable y, then next one is character variable, let z. These are the union members. Then this x will require 4 bytes, this y will require 2 bytes, this z will require only 1 byte. Now what is the maximum requirement? That 4 bytes. That only that much space will get allocated for one variable of that union, and that memory will be shared by all the members. Then you cannot store at the same time all the members of that union. Means suppose you have created one variable of that union. For number 1 you want to store a value. Suppose you have created any other variable at number 2. For that you want to store character value. No problem, you can do that. Getting? But for one variable, only one, that 2 byte space will get allocated in a memory. That should be shared by A as well as CH. This is only the concept of union. And this is the difference between structure and union. Here struct keyword is used while creating that structure. Here union keyword is used while creating that union. Okay, the syntax is same. Now here how much space will get allocated for one variable of that structure? Whatever space required by all the members, that will be added, and that much space will get allocated for one variable of that structure. And here how much space will get allocated for this one variable of that union? Whatever highest memory requirement, that much space will get allocated for one variable of that union. Getting? Here how the memory allocation will be? See here, first for num1, in case of structure I am talking about here, for that contiguous block of 2 plus 1, 3 bytes will get allocated. These 2 bytes, first 2 bytes will be of A, and the next 1 byte is of CH. Means suppose here address is 100, here of course address is 102. Getting? Means suppose you try to display addresses of A and CH, then you will get different memory address, and from that you can say that whatever memory allocation, that is different for each member. Okay, but here in case of union, see, if you try to check what is the address of A and CH, how to check it? Just in printf you can write that address of A. We have to use like num1.a. Okay, if we try to check what is the address of that num1.a using address of operator, just write this statement in printf. For num1, only 2 bytes will get allocated, and that will be shared by A, these 2 bytes, and from that 1 byte will be shared by CH. Getting? Now here let address is 100. Here it may be 101, no problem will be there. Getting? This num1 variable will have both the members, no problem. In that there is no any problem. It is just like a structure. Means what one variable of that structure is having all the members with it. Here again that one variable of union will have all the members with it, but at a time we can use only one member. Now see, here suppose I am trying to display address of this A member of this num1. How to do that? Just we will write printf, then here we will write %u for unsigned integer. You can also use here %x to display address. Then how to display address? Using ampersand operator, that is address of operator. And here how to fetch A? Again same thing, just like structure, using dot operator or using arrow operator in case of pointer. Now here we will use dot operator because num1 is a normal variable of that union. Now num1.a, how to write here in this way, num1.a. Now whatever address we will get here, that is, let it is 100. The same address we will get if we display num1.ch. Num1.ch address, like printf same %u comma ampersand num1.ch. Again you will get same address like 100. Now from that you can say that the same memory will be shared by both the members of that union. Now where to use this now? Because we can group together multiple data type elements, but at a time we can use only one member from that union. Then what is the need of using this? Better than we can use structure, but not like that. We can use union where there is a situation like we want to store some data, but means either or situation is there. Means I want to store age of a student, but I don't know the exact number of years. There we have to give facility that user can enter birth date or user can enter age, anyone. No, both are not compulsory. In that case we can create union like this. See, like union age, this age is capital here, and here we can store age in integer format, or we can store birth date. That birth date is a character array because a birth date may be a string. This is what? This is nothing but a string. We have to store that birth date in the form of string only. There is no any other way. That's why we'll store like char b date, and here we can specify maximum 15 characters. Now in this way we can create age. Now whenever we create one variable of that age like this, union age, let one variable is a1. Now here this a1 will have both the members like age as well as birth date, but at a specific point of time we can use only age or only birth date. We can store either age or either birth date. Both are not necessary. There is no any compulsion that you have to store both. In this case, either user will store age or user will store birth date. Here we can use this union concept. Getting? To save space. Because instead of that, if we are using let struct here, then how much space will get allocated? Like 2 plus 15, 17 bytes will get allocated for one variable of that age structure. Instead of that, if we have used union, then for one variable of that union, 15 bytes will get allocated. That is better. We are saving space here because everything is not compulsory here. There is no need to store this one as well as this one. Anyone? Okay. In this case, we can use union instead of structure. Get it? One more point is there, union can be a member of structure and structure can be a member of union. Getting? Means suppose I have created one age union. Now I want to create one employee structure, and then in that I want to store age of that employee. But I don't know user is going to whether enter age, exact number of years, or user is going to enter birth date. Any one user will enter. In that case, how we can create structure and how we can declare this union age as a member of that structure, that I am going to explain. Now see here, I am creating one employee structure. It is having employee ID, employee name, and I want to store age of that employee, but I am not sure about whether user is going to enter age or birth date, but it may enter any one. Then we can use this union age for as a member of this structure. How? See, in this way, union age, let P, in this way. Getting news, any other members you want to declare, like address of that employee, salary of that employee, that you can do here. Now what will happen here? See here, let our employee structure is like this, and how much space will get allocated for one variable of that employee. Here let E is a variable of that employee structure. Now for E, 2 bytes for this employee ID, 2 plus this 20 for that name, that is 22, and how much space will get allocated for that P? 15, because maximum storage requirement for this age union, that is 15, means one this member is members requirement is maximum requirement, that is 15. That's why for P 15 bytes will get allocated. Now 2 plus 20 plus 15, 37 bytes will get allocated for one variable of this structure, that is E. Now E will have employee ID. How to access? E dot employee ID, then E dot emp name, and E dot P dot, because P is again a union variable. Okay, P is again union variable because it will not have, that's why it will not have its own existence. It is having internally different members again. That's why again we have to fetch that using object dot. Okay, that's why E dot P dot age, either we can store this one or E dot P dot birth date. Both are not at the same time. Okay, for one employee we will store age, for next employee we will store birth date, anything. Okay, now this is the use of union. Means union can be a member of structure. In the same way, structure can be a member of union. This is all about this union concept. In the next session we will see dynamic memory allocation concept. Till that, bye bye, take care.